If you want to learn about debugging Arduino, you are in the right place. This is part 3 of a 3-part series where I spoke with embedded engineer Nino Vidovic from SEGGER Microcontroller. SEGGER is a company that makes tools for debugging and all types of embedded development type tools. In this video, we are going to talk about using their embedded studio to debug Arduino. Now, all of the tools and all of the software links that we refer to are going to be in the description below. So if we mention a link, check out the description, it's going to be there. Now, if you haven't seen part 1 where we talk about debugging in general, you want to check that out. And also in part 2, we talk about debugging specifically with Arduino IDE 2.0. Okay, without further ado, let's go ahead and jump into this. So I'm really happy with what we've done
Yeah.
right now in the Arduino IDE. I'd love to like switch, and I'd love for you to demo on your
Mhm.
machine using the SEGGER toolchain and maybe
Right.
walk us through that. And perhaps we don't need to get as detailed.
Yeah.
Maybe you can kind of keep it at a level where you're okay with
Sure.
that.
Maybe one thing worth mentioning here before we switch to Embedded Studio, as mentioned, we have this universal debugger Ozone. You can also use it with the J-Link Edu Mini. You just might get the next screen, educational use only. Press OK. You have the same feature set. And then what you can do is the Arduino IDE will create this output file for the debugger to read from and to know what application to program. And the same file that Arduino IDE now is using, you can also use in Ozone. So you also have the option to use Arduino as your tool chain to write your code, to prepare a thing, click verify, and then as we saw in the console output, you also get the path to the folders where this file has been compiled to or copied to. And the same file can now be used to create the Ozone project, and you can enjoy also your whole debug experience within Ozone with all its features and stuff like that. So maybe put a link also below the video. I don't know how you want to handle this, but yeah, there's also a guide, I think also on the Arduino webpage, but we also have one in our wiki that shows exactly this setup. So that way you could even debug Arduino boards that are even not currently supported for debugging from Arduino IDE side. But once you generate this output file, you can load it up with Ozone and still debug it, for example, for the Uno Minima, for example.
Okay. Can I just read that back to you just to make sure I'm following? I
Okay.
think I'm following, but so what you're saying is, let's say an Arduino person, I'm developing in the Arduino IDE.
Yeah.
I've written a program and I'm running into a bug and I'm like, man, I really want to be able to debug this thing.
Yeah.
You're saying when I've compiled the program, it's going to generate a file, which I can then use that file to I can then use that file in Ozone
Yeah.
to debug, or is it like would Ozone, this software tool, would
Mhm.
that be open side by side with my Arduino IDE? And like that's where I
You can
think I'm
open it side by side, but the Arduino IDE would just create this file and you can minimize the Arduino IDE.
okay.
And in your Ozone project, you have set the path to this file that's every time generated when you click verify. And then Ozone will tell you, oh, the file has updated. They want me to load it to your target device. And then it will download it and start the debug session just as we saw in the Arduino IDE.
Okay. All right. I got
And
you. So
this works for every ARM-based Arduino board.
okay, fantastic. So instead of using the Arduino IDE interface we just talked about as far
Yeah,
as like the debug stuff, now I'm using Ozone,
yeah,
but I'm still like it's the same tools, like the
right.
step into the step,
Yeah,
but I've still been able to write my code in the Arduino IDE. And
yeah,
if I want to make a change to the code, I'd
yeah,
just go back to the Arduino IDE.
yeah.
I'd make those changes. I'd verify, and I'm assuming that that file path would stay the same then. So is that right? Would
Yeah.
Ozone still be pointing to that? And so I could
Yes.
kind of like,
So
okay,
with the Arduino V2, the output path stays the same, so Ozone can reuse the file and
okay.
notices every time you hit verify, oh, something has changed.
So that's good to know. We'll definitely link to that. And
Yeah.
maybe at some point in the
Yeah.
future, we
Great.
can demo that too. But I
Yeah.
guess now maybe we jump into
Sure.
kind of going bare metal on a chip.
So yeah, we have this IDE. It's called Embedded Studio. Can also be used for private and educational purposes, also for free. And I've prepared a little bit something here, and we also have a dark mode, so nobody's scared, right? We have all the preferences here. And what I wanted to show is I have now hooked up the same setup that you just showed with the Arduino IDE, same board, same J-Link, everything is the same. But this time we're not using any of the Arduino libraries or the bootloader or anything, but essentially your chip is clean. There's no code on there, and all the code that gets on there is written by us, right?
Gotcha. Okay.
Because as we saw earlier in your demonstration, a lot of stuff happens before main, right? And this takes away a little bit of memory space. It might also do some interrupts without your knowledge in the background, which maybe you don't want when you're doing something more time critical or so. And yeah, and then if you go like bare metal, you literally have full control from the reset handler. So what happens directly after reset, the first instruction is executed, you have essentially prepared or written it.
Okay. Wow. Cool.
So when you start Embedded Studio the first time, I'll maybe show how this looks like. So I'll close this solution. So solution is what we call our sketches or projects, right? And
okay, a solution. All right,
so
gotcha.
this is how Embedded Studio usually looks like. What we also have board or chip support packages, which you can find in our package manager. Where is it? There we go. Okay, we have new packages. That's great. And now you'll find here tons and tons of devices. As said, as SEGGER, we support more than 10,000 target devices. So we have Amic Micro, Analog, Atmel, Cypress, Giga Device, Infineon, Microchip, ST, NXP. So they're all here. You can download these packages and start your projects. This is also what I've done with the sample. On the Maker Wi-Fi board, we have the so-called SAMD22 from former Atmel, now Microchip. So all you have to do is install this CPU support package. It's already installed, so we don't have to do anything. And what you then do is you go to File, create a new project, search for the package we have just downloaded, so SAMD21. Now I have several options. You can do a C executable. This is what you want to go for. But you can also have an assembly-only project. You can also even use an external toolchain if needed, or you make a library project. This is also possible. So you have to create a library that could execute on such a target device. But yeah, so just to testing. So give it a very good name, like test 2315, whatever. You select the target device name that you have on your chip, which in this case is, I think, the G18A. The rest you leave as usual. Just press next, finish, and this creates for you a little Hello World project.
Oh, okay. All right.
So here we go. We have this project now. We have seen some files here that are loaded in, and we see the main C. And again, we see our beautiful main function, and we see some Hello World printf. And what I'm going to do is build it. You can also do this with shortcuts. F7 would be the shortcut here. So this is what in the Arduino IDE you know as verify. And now we start the debug session. You can also just directly start the debug session. It will always auto-build if you have made changes. And if you press go, we will see that there was a little pop-up. This was the Flash download, so it's J-Link is very fast. So I don't know if you caught it on stream. But yeah, here we are. We are at the main function. We have this little I variable. We have a locals window as well, as you have just seen. We have the registers here. We have globals, like we saw before, the system core clock in this case. let's set it to decimal so we can read it. So it's 10. Is it 10 megahertz or 1 megahertz? 1 megahertz. And autos would be something like, depending on the context, it shows different variables. And we have, of course, also a watch window here. So yeah, and if I can also set breakpoints and everything. Let me see if, oh no, I have to press the function key. Let me see. All right. So I can set a breakpoint here. We have also these control buttons like run, step over, step into, step out of, and stuff like that. And yeah, I click run. I hold at this breakpoint. We see that I is not initialized yet, so it's some random number. Once we step into the for loop where it's initialized to 0, we see it's at 0. And now if I let the for loop running, we should see in the debug terminal all the beautiful prints. It went very fast, so it's that fast because it's using this SEGGER RTT terminal technology, but this can be used on any Arduino, Arm, Cortex-M as well, but you would have to do it bare metal because it's not in the Arduino libraries.
Okay.
And yeah, this would be a simple hello world. Now I wanted to do the let's say the embedded variant of of hello world is a Blinky, of course. So I created this also based on the same hello world sample, and now I added some code. You see here these functions: BSP init, BSP toggle LED, and including a little header here. And what this does is it uses the functions from this file here that I've written. And what it does, it defines essentially for you what the Arduino library does. So it defines the base registers for the port A GPIOs where the orange or yellow, I think it's yellow LED on this board is located. It initializes it. And I have these functions like set LED, clear LED, toggle LED that I can just call from my main application because I have included the file. And if I let it run, and now we again can step into functions. I'm now in the. I clicked in the assembly window. So this is something that was missed that we didn't see in the Arduino ID. This is the actual machine code that's executed. So you see here, these are the addresses, and this is the bytecode that's executed.
Oh wow! Okay.
And this is explaining what registers are. Like you have a store of this value R0 to the stack and stuff like that, or the stack pointer is put into R0 and stuff like that. So you can see what the machine is actually executing. But if I highlight the C window, it will go. Oh, it's still here. Okay, let me run to a breakpoint then. Here we go. Now I can step over. Or is this step into? Oh, I'm pressing step into. Yes, I should. As you said, we should read the tooltips, right? And yeah, you see here, we are now in the function BSP init. We're initializing the lines. And here we have macros, which are set up here. And this is actually, you're literally accessing now this address with this offset on the microcontroller. So this is always what a lot on low level is happening in C if you're changing register values.
Right. Okay.
And yeah, we can just go through here, step out. And yeah, if I leave this running, the LED will be blinking. We are again with our printf. I made a poor man's delay here with a while -1, but it does its job, right?
Yeah.
And, I touched the cable. That's something happened. But it's blinking. I think it's not easy to see. Oh, I touched some USB cable. Something got disconnected. Don't touch your setups while the code is running. Yeah, but yeah, essentially you can. This is how you would do it bare metal. So you would have to implement all of this yourself, write drivers and stuff like that. So as you said, a lot of the heavy lifting is done by Arduino for you. But if you have a custom board, if you want to have the whole resources of your target CPU available to you, then essentially you need to, or you don't have much of an option than to go with such a bare metal setup. But to make the life easier, a lot of silicon vendors also provide parts of these drivers for chips. And there's also from ARM at least, a standardized CMSIS interface. It's a Cortex M something system files in it something. It's essentially a standardized interface which gives you such a header that's defining the whole CPU. So if you go into this function in this header and go to the header from the CPU, then you'll see that it defines all kinds of things that can then be called from your main function.
Okay, so like a whole set of utility functions
Like
that you can
everything,
use.
like ADC, your deck, your
Okay,
whatever features this chip has, I square two, X square has, real time
right,
clock.
right. Okay, so it's not
All
like,
these
yeah,
things
okay. There's
you
still a
can
lot of that.
call,
Yeah,
yeah. So you
still
could
a lot of
call
help
these
there. Okay.
macros directly from your function and from your main function. So you don't start at scratch. And this shows essentially everything that's also in the device's reference manual, right?
Nice. All right, so Embedded Studio
Yes.
that you were just showing us, that is available for, okay, so you can use it for non-production code if you have a EDU, if you've got the JLink
I mean,
EDU version. All right.
yeah,
If you
yeah.
go with the JLink plus compact,
Mhm.
then you can use that Embedded Studio for
That
production
would,
code. Is that right? Or
it would be an additional license. You can
okay.
evaluate it for free. So we don't, we have the WinRAR license model, kind of like give it a try, evaluate it, but
Gotcha. Okay.
once you go commercial or start the real development,
Right.
hit us up, we will provide you a license.
Yeah, absolutely. Okay. And yeah, I imagine most of the time you're working for a company, they're buying, they've bought the license and you're just,
Exactly.
okay. Yeah.
But we want everybody to at least have the chance to try it, so we're not cutting down any features or limiting anything. You have the same feature set. It just
Yeah,
tells you,
absolutely.
hey, you don't have a license.
Right,
Right.
right. Yeah, I guess you know what I'm so what I love programming in Arduino. I like the ecosystem. I like
Right.
how easy it is. But one of
Yes.
the things I really like about Arduino, and I think sometimes gets downplayed, is the work that they have done to bring so many people into STEM. Because there's a lot of talented people out there, a lot of talented young
Exactly.
people. They
Yeah.
could go into finance. They could go into all these other fields, but if we can start getting people, I feel like we can, Arduino stuff, embedded stuff is so much more exciting than finance. So
Yeah.
like we
I
can bring
agree.
this down, get, like we're really fighting to try to get, more people in STEM fields. And like, so I think it's good. And when people start young and they get into this, but then they can still get exposed to like the tool chains you're referring to, that you've
Mhm.
just kind of demonstrated, like
Right.
allowing those people to get access to that type of stuff can be really beneficial to them
Yeah.
to,
So
you know,
maybe worth mentioning at this point, while you mentioned STEM fields and universities and stuff like that. So if you're at an university or at a college or whatever, we actually have a SEGGER University program, a partnership program, something like that, where we cooperate globally with different all kinds of schools and stuff like that, and professors and even students in their theses and stuff like that. So if you're interested, feel free to contact us if you have an motivated professor or teacher who likes to make a workshop and stuff like that. We can talk about hardware. We have all this like all our software products. So we don't only have the debug probes, the analysis tools, the IDE, the tool chain. We also have middlewares. So we have an USB stack, we have an RTOS, we have a display driver. We have, so all these embedded components are also for free for private and educational use. So if this is something you're teaching and you want software that it's working for 30 years and a lot of commercial
Right.
customers are very happy with it, you can simply use it, right? And we can maybe link also the university program for anyone interested. Just contact us if you have interesting projects, if you maybe even if you need sponsoring. So we are sponsoring a couple of these how are they called? It's student formula racing teams,
Okay.
stuff like projects like that, or
Right.
innovative student projects. Like there was some propulsion lab in the US where some student team was literally building a rocket engine as a student project, right? So and so all kinds of projects were involved. And this is I was at some point at such a university, and I remember that I had to work with crappy tools, and it was no fun, and this is also for me a bit of the way to give back to my
Right.
to my past me, to maybe make it better for somebody else, right?
Oh, that's awesome. Yeah. This has just been fantastic, Nino. I cannot tell you how much this has blown my expectations. I knew we had a lot on the plate. Like there was a lot of stuff I wanted to talk about. And we talked about all of it. Like
Yeah.
there's there's nothing I feel like I didn't cover or that we didn't cover together that I had questions about. I just want to just say thank you for being so gracious with your time, just to
You're
the whole
welcome.
Segger team for, allowing you to take the time to do this. And I
Yeah.
look forward to getting this out there, getting this into people's hands. So thanks a ton. Is there anything you want to leave us with? Any thoughts?
Debugging is important. So get your setups. Like I have a lot of customers that come to us mid project when they have realized we should have gotten a debug setup. So even if you're just a maker and you think your project is going to be a small one, sometimes they grow big. And then you're quite happy that you had thought about this option from the beginning and can fix things or improve things, right?
Right. Oh, that's great. That's a great place to end. Thanks so much, Nino. Thanks a ton. Well, if you are still watching, that means you are absolutely into Arduino and learning about debugging and all this stuff. I hope you had as much fun as I did. I learned so much from Nino, and it was just so generous of him and Sega Microcontroller to lend so much time to help develop this. Now, if you want to up-level your Arduino programming skills, I highly recommend checking out Programming Electronics Academy. It is a training program that's been designed to help you build confidence when you're getting into Arduino programming and building your own projects. So you can check it out at programmingelectronics.com.